Hello, Hello everyone. Today we are going to look at probability distributions exercise 11.2. Before that, let us review some concepts here. Probability mass function definition. So if x is a discrete random variable with discrete values x1, x2, so on till xn, then the function denoted by small f of brackets or p and defined by f of x is equal to probability that the random variable a capital X is equal to xk, where k runs from 1 to n. This is called the probability mass function of x. So the theorem for the probability mass function f of x is a probability mass function if and only if it satisfies the following properties for the set of real values x1 through xn. And the first property is that f of xk is greater than or equal to 0 for k 1 through n. Second property is that the summation of all f of xk is equal to 1. So next we move on to the cumulative distribution function definition. So here we have the cumulative distribution function capital F of x of a discrete random variable capital X taking the values x1 through x3 such that x1 is less than x2 is less than x3. Probability mass function f of xi is given by capital F of x. Probability that random variable is less than or equal to small x, which is equal to summation of f of xi, where x belongs to a set of real numbers. Now, in the first exercise, we will be only focusing on discrete random variables, so we can use the summation. Next, we look at how to get the cumulative distribution function from the probability mass function. So by definition, you know that capital F of x is summation of p probability x equal to xi, where xi is less than or equal to x. So we can get the difference of two consecutive f of x that will give the probability mass function. So this jump is what we need. Suppose x is a discrete random variable taking values x1, x2, x3 such that x1 less than x2 and f of xi is the distribution function, then probability mass function small f of xi is given by capital F of xi minus f of xi minus 1. So this is the jump which defines the mass function. Now let us move on to the exercise here. So we will be looking at questions 3, 4, and 7. Question 3 is that find the probability mass function and the cumulative distribution function of number of girl child in families with 4 children, assuming equal probabilities for boys and girls. So here the random variable x is number of girl childs in family. So we know that either there can be all boys, in which case we will have 0 girls, or can be all girls, in which case we will have 4 girls. And the values are 0, 1, 2, 3, 4. Now the total possibilities, if you know from combinations and permutations chapter, is that say the first eldest child can either be a boy or girl, so it is 2. The second child can either be a boy or girl, so it is 2. Similarly, we have 2 to the power of 4, which is 16. This we studied in binomial distribution. Now, number of ways we can have a 0 girls is that only 1 is possible. And number of ways to have 1 girl is that any of the girls any of the children could be a girl, so it is 4. And third possibility is that we have 2 girls in the family. So out of the 4 girls, 2 can be 2 of them is 4C2. So we have 6. Similarly, for 3 girls, it is 4C3, and by the property we know that 4C3 is equal to 4C1, which is 4. And number of ways for 4 girls is obviously 1. Now, on the probability mass function, we divide the possibility divided by the total values in the sample space. So for 0, we have 1 by 16. Possibility 1 by 16 is the value in this tabular form. To have 1 girl, it is 4 by 16 or 1 by 4. And for 2, it is 6 divided by 16, which is 3 by 8. And for having 3 girls, it is 4 divided by 16, which is 1 by 4. And to have 4 girls, it is 1 by 16 again. Now we have to find the cumulative distribution function, capital F of x. So that is obtained using this definition that capital F of x is equal to summation of probabilities, capital X equal to xi. So we know that f of 0, that is 0, capital F of 0 is only 1 by 16. For capital F of 1, we add the probability mass function of 0 and 1. So that gives us 5 by 16. And to have capital F of 2, we add the previous value 5 by 16 with the probability mass function at 2. So it is 5 by 16 plus 3 by 8, which is 11 by 16. And for capital F of 3, it is 11 by 16 plus 1 by 4, which is PMF at value 3. So, and the final value, the function settles at 1. So when you tabulate this, we have the values at small x values at 1 by, at 0 it is 1 by 16, at 1 it is 5 by 10, at 2 it is 11 by 16, 3 it is 15 by 16, at 4 it is 1. We can show this solution in form of this diagram. It shows a jump at 0, at 1, at 2, 3, and 4. And this is the way in which we write the final solution, that f of x, the capital F of x is 0 minus infinity to 0. And then we have 1 by 16 between 0 to 1, and 5 by 16 between 1 to 2, 11 by 16 between 2 to 3, 15 by 16 between 3 to 4, and it is 1 for all values above 4. So next we can move on to the next question, which is, suppose a discrete random variable can only take the values 0, 1, and 2. The probability mass function is defined by, for here it is given, a formula is given for the probability mass function, and we have to find the value of k and the cumulative distribution function. And this value, which is capital P, probability that x is greater than or equal to 1. So for this solved solution, we use the property of probability mass function. First we have to do PMF is equal to f of x. So we have the question number 4. The PMF is given to us as f of x equal to x square plus 1 by k, where x is 0, 1, and 2. So the capital X value, random variable, belongs to the set 0, 1, and 2. To calculate the PMF at 0, we substitute 0 in the expression. So we have 0 square plus 1, which is gives 1 by k. Then we have 1 square plus 1, which gives 2 by k. And then 2 square plus 1, which gives us 5 by k. Now this we have the capital X values here, and f of x is 1 by k, 2 by k, and 5 by k. Then we use the property of PMF that sum of all three is equal to 1. So we add all the three and we get 8 by k. So k's value is 8. Now the tabular, we tabulate the PMF as capital X is 0, 1, and 2. So f of x is 1 by 8 at 1 random variable 1, it is 2 by 8, 1 by 4. And the random variable 2, it is 5 by 8. Now to find the cumulative distribution function, we have capital F of x, which is defined as capital P small x less than or equal to capital X. So this is given by the summation xi less than or equal to x. So capital P x equal to xi. Now we know that for f of 0, it will be 1 by 8. The value function f of 1, it will have the jump at that point. So it will be 1 by 8 plus 1 by 4, which gives us 3 by 8. And for f at f of 2, capital F of 2, it will be 3 by 8 plus 5 by 8, which gives us 1. Now we can plot this jump function, and this is the final way we write the solution, that f of x is equal to 0 from minus infinity to 0. It is 1 by 8 from 0 to 1. It is 3 by 8 from 1 to 2. And from 2 onwards till infinity, it is 1. So with this we finish this solution. And for p x greater than or equal to 1, we have to just add, these functions 3 by 8 and 1 and 1 by 8. We have to add 3 by 8 to find the value of p x greater than or equal to 1. We add the PMF of 1 and 2, which gives 1 by 4 plus 5 by 8, which gives us 7 by 8. Now we move on to the next question, which is question number 7, that the CDF of a discrete random variable is given by capital F of x is equal to 0 from minus infinity to 0, 1 by 2, and there are jumps at 1, 2, 3, 4, and stops at 4. Now the question is to find the probability mass function, and then the probability that the random variable x is less than 3, and probability that x is greater than or equal to 2. So to look at this solution, we have the PMF, we know by definition, and that f of 0 is, small f of 0 is the difference between capital F of 0 and the value f of 0 just to the left side of 0, so 0 minus. So it is half minus 0, which is half. Now we know that f of 1, similarly f of 1 is the jump which is there in this capital F function. So the jump is f of 1 minus f of 0, 3 by 5 minus 1 by 2, which gives us 1 by 10. Small f of 2 is capital F of 2 minus capital F of 1, so on. So we get 1 by 5 here, and small f of 3 is the difference between capital F of 3 and capital F of 2, which gives us 1 by 10. And small f of 4 gives us the difference between capital F of 4 minus capital F of 3, which is 1 by 10. So in the tabular form, we can write that the cap x random variable takes 4 values, 0, 1, 2, 3, 4, and the corresponding small f of x is 1 by 2, 1 by 10, 1 by 5, 1 by 10, and 1 by 10. Now we can also, for visualization, show that this diagram, but it is not necessary to be drawn. So at 0 we have half, and we have this stem plot which shows the value f of x. Now the second question was, the second subsection is that capital P x less than or equal to 3. So for this probability less than 3, we had the PMF of f of 0, 1 and 2. So because the random variables is 0, 1 and 2 is less than 3. So we add 1 by 2, 1 by 10 and 1 by 5. So we have 5 plus 1 plus 2, which gives 8 by 10 and 4 by 5. Now the third subsection is that capital P of random variable x greater than or equal to 2. So that is given by small f of 2 plus f of 3 plus f of, because the values it can take which are greater than or equal to 2 is 2, 3 and 4. So we have 1 by 5, 1 by 10 and 1 by 10. This gives us 2 plus 1 plus 1, which gives us 2 by 5. So with this we are able to get some understanding of the CDF and PMF discrete variable problems. So please ask your doubts in the comment section and let me know if you want the explanation in Tamil. உங்களுக்கு தமிழ் எக்ஸ்பிளனேஷன் வேணும்னாக்க சொல்லுங்க, நான் அதுக்கேற்ற மாதிரி தமிழில் மாற்றி the problems explanation நான் கொடுக்குறேன். Next, we'll go to the next exercise in the next video. Thank you.